Okay, in this question, we need to start off by finding what the determinant of a minus lambda I is. So first of all, we're going to work out what is a minus lambda I. So we start with our matrix A, and lambda I means instead of being 1, 0, 0, 1, we're going to have lambda 0, 0, lambda. Normal takeaway rules apply, so we'll have 2 take lambda, 5, 4, 3 take lambda. Now the next thing we need to do is work out the determinant of a minus lambda I is equal to 0. So that means that the determinant of the matrix we just found out has to be equal to 0. Remembering that these straight lines refer to the determinant. So remembering that the rule for determinant is that if we had a matrix A, B, C, D, and that would be AD take away BC. So applying that rule here, we need to do 2 minus lambda multiplied by 3 minus lambda, take away 4 times 5, and that determinant must be equal to 0. So now we're going to expand those brackets. So 2 times 3 is going to give me 6, minus 2 lambda, take 3 lambda, plus lambda squared, take 20 equals 0. I'm going to rewrite this in a quadratic format. So we're going to have lambda squared, we've got minus 5y, and then we've got a negative 20 plus 6, so minus 14. Now I need to factorise that, so I'm looking for factors. So I'm going to use 7 times 2, because that will give me the negative 5 here. So lambda takes 7, multiplied by lambda plus 2, equals 0. So if lambda take away 7 is going to be 0, that would give me that lambda is equal to 7. Or if lambda plus 2 is equal to 0, that would give me a value of lambda is equal to negative 2. So therefore, we've worked out our eigenvalues, and they're 7 and negative 2. So that's the answer to part A. Now for part B, we've got to work out the eigenvectors. So we're going to start with knowing that AX is equal to lambda x. So we've got that now AX is going to be equal to 7x, or AX is going to be equal to negative 2x, using those values that we've just worked out. So now we're going to let x equal AB, so it's in a matrix format. So AX can now be written as, I'll put A in. So A is 2, 4, 5, 3, and X is AB. And for lambda X, we'll have 7AB. And I'm just going to do the other ones down here. So now for the other AX, we've got 2, 4, 5, 3. X is AB. And we'll have negative 2 there for our other eigenvalue, and AB. So we're going to multiply the top part of the matrix, so we'll have 2A plus 5B, and that will be equal to 7A. Rearranging that, we've got 5B is going to be equal to 7A, take away 2A, which is 5A, so therefore we've got that B is equal to A. So X is any vector of the form AA, because what we've done is here, this was our value for B, but B was equal to A, so we've substituted that in. Now we'll do the same thing for our other possible eigenvalue of negative 2. So multiplying here, we've got our 2A plus 5B, and on the top line here we've got minus 2A. So rearranging 5B, we've got negative 2A minus 2A will give me minus 4A. Dividing both sides by 5, we've got minus 4/5 A. The textbook example does actually leave it in the fraction, but when you go and check your answers for this question, they actually give them as whole numbers. So if I multiply both, I'll leave it as the textbook had it first. So we'd have X is any vector And now for the AB, we've put A and then the B is negative 4/5 A. That's like the textbook examples, but as I said, when you go to the answers, you'll find that they use whole numbers, so they simply multiply by the 5. So 5A and minus 4A. So now we can sum up our answer. Therefore, the eigenvectors so any vectors of the form AA or 5A negative 4A. And that is our answer.